Good morning. This is tutorial number 2 in MATLAB, and what I want to do is tell you a way to learn MATLAB on your own using initially some of the props that I'm giving you, but you should try to develop the ability to learn things on your own. So here I have put a tutorial set of problems. And I don't want you to just listen to this recording and feel that you have understood it. That's not going to help. And I don't want you to just type the commands that you see on the worksheet and get the output and you feel that you have done your job. You're not going to learn. So this is an opportunity that I'm creating for you to think about it. And so I would like you to approach it in a particular fashion. And that is the following. There are a number of simple statements that I have constructed. And I want you to think about it and predict what MATLAB output will look like. Okay, once you have done that, then actually enter that command and see whether you get what you expected. If you don't get it, then think about it again, trying to understand why your thinking originally was different from what actually MATLAB did. And that process will help you cement in your mind slowly the various features in MATLAB. Okay, so these are going to be random kind of exercises trying to build strength in your understanding of how MATLAB performs. Some of them are about arrays, some of them are about logical operations, operations with arrays and things like that. So let's begin. Okay, so let's with the first exercise. So here I have an assignment statement. I'm creating an array A and setting it equal to 1 space 2 space 3, and then I have these 3 dots followed by, in the next line, 4, 5, and 6, and I close the square brackets. So I want you to think about what this dot 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 does. So it's basically a continuation operator, meaning I'm going to continue entering that line onto the next line, so don't interpret it until I finish entering. Okay, so that's the meaning of it. So when I enter that, I should create a vector of length 6, a row vector of length 6, and that's what I expect, because it's basically continuing onto the next line, but it's part of the same command. So if I take that and command window 1, 2, 3, dot, 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 enter 4, 5, 6, I should get a variable as 1, 2, 3, 4, 5, 6 as a row vector. And that's what I expect and that's what I get. Okay, but in the next exercise, I have the same thing, A equals 1, 2, 3, dot, 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 and I'm putting 4, 5, 6 on the same line. Now, you might think that because I'm continuing on, it should basically append what the 2 numbers and produce the same result. Let's see whether that happens. So I have 1, 2, 3, and then I have dot, 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 4, 5, 6. But even as you type, notice that the color changes for 4, 5, 6. So there's something that is funny happening. So if I hit enter, it's not interpreting it. So what is happening, I think, is that dot, dot, dot is treated as a continuation, and anything to the right is ignored. If that is true, if I complete it by 7, 8, 9 on the next line, I'm slightly departing from what I have on the exercise, then I should get 1, 2, 3, and 7, 8, 9. Okay, why did I not do the other way? 1, 2, 3, dot, 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 4, 5, 6, and put a parenthesis, and nothing happens. Then I say 4, 5, 6. If I enter this, I wouldn't know whether I'm getting the 4, 5, 6 from the first line or from the second line. Okay, so that's why I changed it spontaneously to 7, 8, 9 to show you that it indeed picks up from the next line and it ignores everything to the right of the dot, dot, dot operator, which is a continuation operator. That's very important to understand. And in the next example, I have again A equals 1, 2, 3, but I put a semicolon and then dot, 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 4, 5, 6. So what this should produce is, a matrix of 2 rows. 1, 2, 3 in the first row and 4, 5, 6 in the second row. That's what I would expect. Now let's see whether I get that. 1, 2, 3, dot, 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 enter, 4, 5, 6. And that's indeed what I get. Okay, so the basic purpose of the dot, dot, dot operator is to allow you to continue to input a very long command, breaking it up into multiple lines, but logically they are part of the same command. Okay, and the next exercise I have is A equals, once again, 1, 2, 3, dot, dot, dot. I'm continuing on to that, but there's just space between the numbers, and then 4, 5, 6, and then semicolon, and then 7, 8, 9. What should this produce? I would expect this to produce an error message simply because in the first row I'm packing 6 numbers and in the second row I'm packing 3 numbers, and that should not work. So MATLAB should give me some sort of an error message. Let's see whether that happens. 1, 2, 3, dot, dot, dot. I'm continuing. 4, 5, 6, semicolon. I'm continuing. So this is still continuing. When does it know that I have finished entering that? Only when there is a matching right brackets. Until that, it will just keep expecting more inputs. 7, 8, 9. If I close this at this stage, it is going to give me an error message. So vert-cat means vertical concatenation. The dimensions are not consistent. It simply means that in the first row I have 6, in the second row I have 3, so it's not going to work. If I had done this, A equals, this is what I want you to do. So I have one seed and I want you to play with it, looking at variations on this. 1, 2, 3, dot, 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 4, 5, 6, semicolon, and then 7, 8, 9. Continue. 10, 11, 12, and then close the parentheses. Okay. It still gives me an error. Why? Because the enter command on line 3 following 7, 8, 9 broke it up into the next line. Okay, so it's actually treating it as I'm trying to create 3 rows in a matrix. I wanted to say, for example, 1, 2, 3, 4, 5, 6 in the first one, then 7, 8, 9 in the next one, and 10, 11, 12 in the third one. So what do I really want to do? I want to create 2 rows. Okay, so I could do this to fix that. 1, 2, 3, dot, 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 4, 5, 6, semicolon, 7, 8, 9, dot, dot, dot. So this says the next line that I'm entering should be on the same as the previous one. 11, 12. Okay, so that works. Okay, so I hope you get some idea about what is the purpose of this continuation operator. Now, you don't have to have the continuation operator. If you just do 1, 2, 3 and then enter, it still allows you to continue, but the meaning is different now. But this is not going to be treated as the same line. It's going to go put the next set of numbers in the next row. 4, 5, 6, enter, 7, 8, 9, and then close it. Okay, so this is going to produce a 3 by 3 matrix. Whereas if we had done 1, 2, 3, dot, 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 4, 5, 6, dot, 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 7, 8, 9, and close it. This is going to put one row vector with 9 numbers on the same row. So important differences that you should understand so that you don't misuse them or inadvertently use them incorrectly. Okay, so much about the continuation line. Now let's look at operations, scalar multiplications. So the next example says, what is the product of 3 times an array which contains 2, 3, 4? Now if the operator, most of them are treated as binary operators. So star is a multiplication operator. It needs numbers on either side. And so on the left hand side it has a scalar, number 3. On the right hand side it has a vector. So what does it do? It takes the scalar and multiplies every element on the right hand side by 3. Okay, so if I have 3 times 2, 3, 4, I should get 6, 9, and 12, and that's what I get. Okay, so I've understood how the scalar multiplication with a vector takes place. The next line I'm saying it is 3 dot star. Okay, so what is the meaning of dot? you have to understand it in the context. Okay, there is a dot star operator which says multiplication element by element. Okay, so if I say 3 dot star 2, 3, 4, I should expect once again the same result, 6, 9, and 12, because it's only a scalar, so there is no difference. There's no need to have a star. It is indeed true. That's what I get. The next one, I say 3 dot dot star 2, 3, 4. What should this produce? Some of you may think that it should produce an error message, but what happens is the first dot is treated as part of the decimal, so it's treated as 3.0. The second dot is treated as part of the star operator, dot star operator. So it should also produce the same result, and it does. Okay, so it's not an error to have, say, 3 dot dot, because the interpretation is one of the dots is representing a decimal number. Okay. The next example shows the same thing, a scalar with a matrix. So 3 star 2, 3, 4. Now I'm not using the continuation operator, but I'm creating the next row of the array, 3, 4, 5. I'm creating a 2 by 3 array and multiplying that by a scalar 3. So the entire element by element is going to multiply and produce for me 6, 9, 12 in the first row, and then 9, 12, 15 in the second row, which is what it does. Now, in the next one, I'm saying I'm making both of them as vectors. So I have 1, 2, 3 dot star 2, 3, 4. So this represents a truly element by element multiplication. That means multiply first element from the left with the first element from the right. 1 times 2, that's going to be 2. The second one is going to be 2 times 3, which is going to be 6. The third term is 3. 3 times 4 is going to be 12. Okay, sure enough, that's what it produces. The next one says the same thing, except I have a transpose. Okay, now this is going to produce an error because I'm taking a row vector and doing an element by element multiplication with a column vector. Okay, I guess one could define an operator where that is meaningful, but in MATLAB's terminology, this is not allowed. So it says matrix dimensions must agree. So when you have an element by element operation, the size of the entity on the left and the size of the entity on the right must agree. Otherwise, it will not carry the operation. So the same thing is true if I have a column vector, element by element, with a row vector. It will produce an error message. Okay, but if I have a column vector with a column vector, now the dimensions match. So it will produce the proper product, which will be 2, 6, and 12, but in the column format. Okay, and the next one would be I'm doing a row with a column. Okay, and without the dot product. So what does that mean? This is well defined, a row with a column, but it's going to be producing the sum of 1 times 2 plus 2 times 6 plus 3 times 4. That is a normal vector product definition. And it produces a scalar number, just one number, because it's a sum of the first element from the left with the first element with the right, take the product, add it to the second element from the left, second element from the right, etc. Go on doing that. Okay, so these principles are applied for any dimension size of matrix. Okay, so the basic thing you should understand from these is that when you have an element by element operation, the sizes must match, and then it carries out, no matter whether it's a vector, scalar, matrix, or even higher dimensional matrices. MATLAB allows 3-dimensional, 4-dimensional matrices as well. And in a similar way, if you have a scalar with a vector, no matter where the scalar appears, left-hand side or right-hand side, the scalar is multiplying every one of the element in the vector or the matrix. Next thing I want to review for you is this precedence ordering. Okay, so here we are saying what will 1 plus 4 times 3 divided by 4 square will produce. Now, in general, the precedence ordering is from left to right. Okay, but certain operations precede the others. For example, exponentiation is done first, then multiplication and division are done, but they are done with equal preference. So then left to right rule breaks that ambiguity if there is any. You can always put parentheses to rearrange the precedence order. In the first case, I'm saying it's going to do 4 to the power 2 first, which is going to be 16. And then it's going to do 4 times 3, which is 12. So 12 divided by 16, which is 3 divided by 4. And then it adds that to 1. The addition is done the last. So it's going to produce 1.75 if I'm right. So let's try 4 to the power 2, 1.75. In the next one, I did 2 divided by 3. The division is first and then the exponentiation. So exponentiation is the highest priority, but by putting the parenthesis, I'm saying do the division first before you do the exponentiation. So it's going to be 2 over 3.66 and then raised to the power 2 and then add it to 1. Okay, so it's 0.6, 0.36, something like 1.4 or something like that. Yeah, there it is. The third one, I'm saying do the addition first on the left side and then do the exponentiation on the right side and then do the division. Okay, so it's 5 divided by 5 times 5, which is 1 over 5, which is 0.2. And there is the answer. Okay, in the next one, I'm saying add 4 plus 5, 9, divided by 9, which is going to be 1, and then exponentiate it twice. So that means it's going to be just 1. 4 plus 5 divided by 9 to the power 2, which is 1. Okay, so it's very important because these errors are the most difficult to find. You think that it is doing in one way and it is really doing in another way. So if you don't understand the precedence ordering, logically, syntactically, there is nothing wrong, but it does not produce the correct answer. Okay, so those kinds of bugs are the most difficult to find. Okay, next one, we're going to do matrix operations using logicals. Okay, so here I'm asked to define a variable called A, which has 1, 3, 2, 4, 5, and a vector B, which contains 3, 1, 2, 1, 5. Okay, so we have seen arithmetic operations. Now let's see what are logical operations. So if I say A not equal to B, so not equal to is going to test whether elements in A are not equal to elements in B. If they're not equal, then the answer will be true, 1. If they are equal, the answer will be false, it will be 0. So the output of this is going to be the same dimension, the same size as A and B. Obviously, if A and B have different dimensions, then it's going to produce an error because it cannot carry out that operation. In this case, both of them are row vectors with 5 elements. So it's going to do an element by element operation. So it's testing for A not equal to B. So in the first position of A is not equal to first position of B. 1 is not equal to 3. So the answer is true. And that's why I get 1 in the first position. Similarly, 3 is not equal to 1, which is true. I get 1 in the second position. In the third position, 2 is equal to 2. So it's not equal to B is not true. So it becomes 0 there. Okay. And if I say A equal to B, double equal. So there is a difference between a single equal sign and a double equal sign. A single equal sign is an assignment statement which says whatever is on the right hand side is going to be assigned to the variable on the left hand side. Whereas a double equal sign says answering the question, are these two the same? Is A the same as the B? Okay, so here again it does it by element, and if the dimensions don't agree, it produces an error. And we're checking for equality. So is 1 equal to 3? No. So the first position will contain 0. Now what I said earlier would be true. So if it's 3 equal to 1 in the second position, no. Okay, so that answer will be 0 also. And in the third position is 2 equal to 2. The answer is yes. So it will be containing 1. So I get 0, 0, 1, 0, 1. 0, 0, 1, 0, 1. That's correct. Okay, so that's how the logical operations work, element by element on the two operands, the two numbers on either side of the operation. So is equal to, is not equal to, is less than or equal to, or less than or greater than. You can do all kinds of variations on these that I would like you to play with. For example, I have one here, A greater than or equal to B. Okay, you can check and see whether it will produce the correct result. So 1 greater than 3, the answer is no, so it's going to be 0. Then the next one will be 1. The third one will be 1. The fourth one will be 1. And the fifth one will be 1. The first one will be 0. The rest all should be 1. If my logic is right. And it does produce that. Okay. Then I have this command, a within parentheses, find a equal to b. Let's first understand what find does, because this is a new function. So you type help find, and it produces a description of what the function does. Find indices of non-zero elements. Okay, so it just finds the position, index position of those elements which are not 0, and returns an index vector I. Okay, corresponding to the non-zero entries of an array X. So let's just play with this. Suppose I say find 102, 104, and see what it produces. Okay, so it produces 1, 3, 4, 6. Well, let's say simply first position is not 0, third position is not 0, fourth position is not 0, and the sixth position is not 0. Okay, so it basically finds, in a sense, positions that are true. 0 meaning false, positions that are true. So if I say find a equal to b, it's going to first produce the result of a equal to b, which is the vector that we saw earlier, 0, 1, 0, 0, 0, 1, 0, 1, this one. And that's going to pass to the find. So the find is going to come up with an answer 3 and 5. It says in the third and the fifth position, it's non-zero. Okay. I guess okay. 3 and 5. So I don't know what happened. I entered something previously wrong. Okay. So find a equal to b says that in the third and the fifth position, I have non-zero elements. Okay. Then, if, for example, I want to select, this is a very important concept. Okay, this is where these such logical operations can be useful. So I have a huge array of data points, and I want to pick only certain elements that meet certain criteria. For example, I have a temperature chart, and it gives me temperature of average temperature of every day in Baton Rouge for 1 year. So I have an array with 356 numbers, and I want to find those days where the temperature is more than 60 degrees. Okay, you could use this kind of a logic to select all those days and print out what the temperatures are. So here, for example, if I say a, find a equal to b, b, first it'll execute a equal to b and produce the vector, the innermost one, and produce the vector 0, 0, 1, 0, 1. It is passed to find, and find says, okay, the third and the fifth elements are not 0, not false, it's true. Okay, and then that produces the result 3 and 5. Then a takes those 3 and 5 and prints out the third and the fifth element of a. Okay, 2 and 5. So this I print out what are those third and the fifth elements. So the numbers are actual numbers. So it is 2 and 5. 2 was the same in both the vectors, and 5 was the same in both the vectors. Whereas find alone returns the position. The third position and the fifth position had the same numbers, but it doesn't tell you what those numbers were. By passing that to A, you can actually say what were those numbers that were identical. So you can say that these are the two numbers, 2 and 5 were the two numbers. And of course, if I do B, find A equal to B, I should produce the same result because I'm picking the same elements from B. Okay, 2 and 5. Now, we already did that A greater than or equal to B. The next one is an interesting one. This shows basically how you can construct progressively more complicated structures in MATLAB. Okay, so here I have A greater than 1 and A less than 5. So it says, now remember, the basic rule. A is a vector, okay, and greater than is an operation, logical operation. 1 is a scalar. So it's going to apply element by element. Is the first element greater than 1? The second element greater than 1? So the result of that is going to be a vector. Maybe we should do that in individual parts first, and then we can check. A greater than 1. Okay, that's going to produce 0, 1, 1, 1. That means, except for the first element, all the elements A had a number greater than 1. So the logical answer is there. It returns 0, 1, 1. And then if you do A less than 5, you can predict what that will do. It will produce 1, 1, 1, 1, 0, because the first 4 elements are less than 5. The last element is not. 1, 1, 1, 1, 0. And then the AND operator examines both these numbers, okay? 0, 1, 1, 1, 1, and then 1, 1, 1, 1, 0, and says element by element again. Now this is a vector. Okay, on both sides we have vectors. Okay, so A greater than 1 and A less than 5. So here we had a scalar and a vector operation which produced a vector. Here we had again a scalar and vector operation which produced a vector. Now on both sides of AND operator you have a vector. So it does an element by element operation and picks out those numbers where both were 1. That means first one not true because one has 1, the other one has 0. Second, third, and fourth both were true. Okay, and the fifth one is 0. So it should produce me 0, 1, 1, 1, 0. 0, 1, 1, 1, 0. Okay. Now, if I save that in a variable called index, sorry, I pass this to find. This is what I'm asked to do next. Okay. So remember, what is find going to do? Find is going to find the index positions where it is true. Okay, so it's going to return, for example, 2, 3, and 4, because these are the positions where that condition is true. So my understanding again is right. Now if I pass index, it's going to print the values of A in those locations 2 and 3 and 4. So these are the only numbers where both conditions were met, that A was greater than 1 and A was less than 5. So this kind of a logic allows you to process large amounts of data where you can pick out data that meet certain criteria. You can construct scripts and functions that will do that. And then I'm asked to type this. If sum of index equals 9, then display the variable. Finally, I'm beginning to understand and end. Now, is that going to be true? If sum of index equal to 9, okay, so index has the variable 2, 3, and 4. So sum probably will add them all up. So 4 plus 3, 7 plus 2, 9. So sum of index will produce a number 9. And I'm asking, is that equal to 9? So the result of this one will be 1, meaning it is true. And the if condition will work because it is true. So it will display whatever that we are typing here. Finally, I am beginning to understand. And remember, when I hit enter, it still waits because the if condition should be matched with an end condition. Only then it processes all the lines. Here I'm not using continuation, but continuation is implied because of the nature of the if condition. Okay, so that covers the logical operations. You should play on your own with additional logical operations. In the next set of problems, it's about for loops. And what we are asked to do is, don't worry about what it produces, but how many times does it execute the loop. Starting from, for example, for time, I'm setting a variable time as the counter, starting from 10, going down in steps of -1 to 0. It'll print basically what the time value is. Okay, so it's going to do it once for 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0. So I predict it'll do it for 11 times, and let's see whether it does that. For time equals 10 colon -1 colon 0, display time, end. So it should produce output saying 10, 9, 8, 7, 6, 5, etc. But I mean, it just produces the variable time. It doesn't produce the actual time. Okay. So how many times did it produce? 2, 4, 6, 8, 10, 11, as I expected. Okay. But let me play with this one for time equal to 10 colon minus 1 colon 0. Display time. And what would this produce? I really don't know. Okay. So will it produce the actual value? Let's try it. So it does. Okay, so then the first instance, time was put in the parentheses, so it's a character variable, so it just prints that character variable 11 times. The second time, time is actually the variable in the loop counter itself. Okay, so it produces the actual numbers 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, etc. Now the second problem for count equals minus 2 to 14, print that many times. So that's going to produce maybe 17 times, because 14 minus of minus 2, which is 16, plus 1. It's always the end minus the beginning plus 1. Okay, so I predict 17 times, but let's try for count equals minus 2 colon 14 and display. Let me just display count itself instead of the string count, the variable count itself. So minus 2 to 14, it did that, but I need to count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yeah. So as I expected, it did the loop 17 times. So the important thing to understand is that for should always have a counter variable that you set up. You can use the counter variable inside the loop as a variable. Its value will be incremented according to the rule that you have on the right hand side. And the rule can have a beginning, an increment, and an end. And any of them can be negative. Okay. So let me pose a question and see what you answer as before I minus 2, 14. Okay. What will that produce? And let's say display count. Before I hit enter, I want you to think about it. So I'm starting at minus 2, but I'm going in the negative direction to minus 4, minus 6, minus 8. But my terminal point is already on the right side of minus 2, 14. So what will it produce? I think it should produce nothing. And it does produce nothing. Okay. And the next question is, in MATLAB, how will you evaluate the following sum of terms? Let n equals 10. So there are 10 terms for x value of 0.5. So the sum we want to calculate is s, which is equal to 1 plus x squared plus x cubed plus x to the power n. So we want the capital N to be 10. We are told that. So you're told create a vector that goes from 0 to 10. Okay, 0 to 10. I guess you don't need that parenthesis. So that created the vector with 11 elements going from 0 to 10. And then set x equals 0.5. Okay, and find the sum of them. So the first thing that you can do without using a loop would be simply calculate each one of those terms. Okay, so let me just say t is equal to x dot to the power. So this is an element by element operation. X is a scalar number 0.5. N is a vector. Okay, so each element is going to be raised to the power x to the power 0, x to the power 1, x to the power 2, etc. Okay, and the result will be saved in a file called t. So it will also contain 11 numbers, because 0.5. So 0.5 to the power 0 is 1, 0.5 to the power 1 is 0.5, 0.5 squared is 0.25, etc. These numbers seem right. Now all I need to do is sum t. Okay, that is the sum of 10 numbers. So I did it without any loop. You could put this all in one if you want. So I can say sum of x dot t to the power n. Sorry, x dot. Okay, or you could do this. 0.5 to the power n, or you could do this, 0 to 10. Okay, so if I want to do it for the first 20 terms, all I need to do is change that to 20. Okay, so it's obviously a convergent series that converges to a value of 2 for that value of 0.5. So what does it converge to when the number is 0.6? 2.5, probably. Okay, so you can see you can take 30 terms and it does go to 2.5. Okay, so this is the real power of MATLAB. You can kind of string together a whole series of operations in one line. The result is passed to another function, the result of which is passed to another function, etc. Nested in a way like that. And I think the next one is, this is a function we're going to develop in the class. It's called Rice-Rashford equation that comes in multi-component Flash. Here we have two variables, z, which has 4 numbers, and k, which has 4 numbers. And then psi is typically called a fraction of the vapor, and that's 0.5. And you're supposed to calculate that function. Okay, let's do it without using a loop. We are asked to do that without using a loop. How would I do that? Okay, so I'll create the vector z, which is 0.25, 0.25, 0.25, 0.25. Okay, and k is equal to 2, 0.5, 0.5, 0.2. And psi is equal to 0.5. So to find all the 3 variables, I need to calculate that function in one line without using a loop. So I notice that there is a sum, so I put a sum. Sum of what? Okay, so inside that I need to calculate the numerator and the denominator. So I can say 1 minus k star z. Will that work? Obviously it won't work. It has to be capital K. Now k minus 1 is a scalar, k is a vector, right? So the result is going to be a vector, element by element operation. You don't need to do anything. But the result of that with z, you have vector on both sides. So you mean an element by element operation. So you need a dot there. Okay. So, and then you have divided by. Now the precedence ordering says I'm going to calculate 1 minus k first, produce the vector, and then produce the product with the z. And I'm going to put a term in the denominator. Okay, so I put a parenthesis there, and it is 1 plus psi times k minus 1. Will that work? Is the parenthesis matched? Okay, well, k minus 1 is going to be calculated because it's within parentheses. That's going to produce a vector. That's going to multiply a scalar. Psi is a scalar variable. Okay, so I don't need a dot there. But the resultant is going to be a vector, but it's added to 1. Okay, so that's also, the 1 is added to all the elements, so I don't need a dot. But the denominator, the entire denominator is going to be a vector, and the numerator is a vector. So I need an element by element operation here, and that produces a vector. The resultant is a vector, which is passed to the sum, and sum takes the sum of all the elements. If I'm right, it should produce a number. Now, the beauty of this is if k had 10 numbers and z has correspondingly 10 numbers, the same expression would work. No matter how many components that I have in my distillation column, the same expression would work. You may want to think about how you would generalize this when psi is also a vector, meaning I want to pass many different values of psi and I want to get a corresponding vector by putting a loop or generalizing without any loop. Okay, so the next question is, what will be the result of entering the following MATLAB? fprintf, I know my fprintf command well. Okay, so I'm predicting that it will predict I know my fprintf command, and then a %string, and the %string is the placeholder. Okay, placeholder, so I'm printing this. So this is the variable. Anything following a comma is a list of arguments that I want to use to print that particular placeholder, the variable. So this is going to produce, I know my fprintf command well, and then put a carriage return to go to the next line. Let's see whether it works or not. I know my fprintf command %s \n end parenthesis comma well. So it prints I know my effort command well. Okay. So what would happen if I didn't put the %string? Okay. It says I know my print command, but it didn't have a placeholder for printing that variable, string variable well. So it did not print that. Okay. So what would happen if I had this /n %s? Okay. These are the variations I want you to play with. Okay. So now I'm saying I know my fprint command, and then go to the next line and print the well in the next line. Okay, and it did that, but finally you notice that the prompt that it puts normally, called the trial, because what I have is a trial license, is printed after this, because this command is executed and then somewhere in MATLAB it has a command that produces the prompt at every command line, and here it is coming after that. So what I really need to avoid this would be to put an n there and then \n. Okay, what will this produce? It will produce I know my fprint command, next line, well, and then it goes to the next line and then puts its prompt. Okay. Notice how the fprintf reuses if the list is more than format specified. So here saying, oh, maybe not, %3i \n. So I have only one format specifier that says use 3 integer positions, I for integer, 3 for 3 digits, and put those numbers in that place, and then go to the next line. But on the right hand side, I just don't have one number, but I have 2 numbers. Okay, and again I'm playing on what we did before. It is 2 ... which means 2 dot is the first decimal place for 2, 2.0. Second is a dot operator that goes with that. Really, we don't need it in this case. Multiplied by 2 times 4. So I produce that it'll produce one line which says maybe not 2, and then the next line maybe not, 4, and the next line maybe not 8, because it has to multiply. Okay, so fprintf maybe not %3i \n and comma 2 ... star 2 4 and that. Okay, so it should produce maybe not in the first line, and then the number 4, and the next line maybe not. So it's reusing that maybe not as many times as needed. Okay, so that's another feature of fprintf that you should know. And in the next one, it says maybe not, the same thing, but 2.0, so it's basically the same. It should produce the same result. But using 3i, because it is 3 integer positions. Okay, but I'm doing the operation with floating point numbers. Okay, so fprintf maybe not %3i comma 2.0 point star 2 4. So it should produce maybe not 4, maybe not 8. On the same line, I missed that part because I don't have a \n. Okay, that is the key, I suppose, in this one. So it should have \n, then it'll produce in 2 lines. Okay, but it uses the integer format. So what happens if I change this to G? Okay, it still does 2, 4, and 8 because these are really integer numbers. If I put 2.1, then I'm producing 4.2, right? 8.4. So the G format uses the general format that is appropriate to this. But if I had used, instead of GI, what would happen? Okay, so wow, it produces exponential. I would have predicted that it will use 3i, %3i, 3 integer positions, because I'm specifying it, but I guess it ignores it. So I don't know much about fprintf. So it is true that maybe not. I don't know fprintf. Alright, I think that covers this tutorial. Play with it more, study every one of them and the response. And more importantly, I hope that you learn a way to learn more about MATLAB. I think that's the most important part.